think we're back again. I'm sorry about that. We're going to cover section 2 of chapter 14. This is acid-base theories. This one can be a little bit more difficult just because there's some concepts there. You got to remember how to do some Lewis dot structures. You got to remember the definition of what a proton is, and it's mostly definitional. Your homework's going to be a little bit more conceptual, but based off of those definitions. And so here we go. We're going to compare and contrast the different models of acids and bases. Three main types of models of acids and bases. We've already talked about the Arrhenius acid and base model, in which an acid donates hydrogen ions to solution and a base donates hydroxide ions to solution. There are two other ones we're going to talk about today, the Bronsted-Lowry form as well as the Lewis definition of acids and bases, and we will take a moment to refresh our memories about Lewis dot structures, and hopefully I can figure out a way to show you how to do that here. That might take me a second. We might have to do that actually in class, or at least our Zoom meeting later. Okay, there are our objectives. Let's see if we can get through these. All right, so first, like I said, it's going to be definitional, primarily definitional today, and then we're just going to practice making sure we know our words. Whoa, I went the wrong way. Right here's where I want to be. Right, and so we're going to look at Bronsted-Lowry acids. So a Bronsted-Lowry acid is a molecule or ion that has a hydrogen ion or a proton donor. So this is very similar to our Arrhenius definition, but now we're going to call, instead of this a hydrogen ion, we're going to call it a proton donor. It has ability to put a proton. If we remember, hydrogen has one proton, one electron. If we strip that electron away and ionize that hydrogen, it's just a proton. So legitimately a hydrogen ion is a proton. Bronsted-Lowry base. A Bronsted-Lowry base has the ability to accept this. A really good Bronsted-Lowry base would be F minus, the negative, the fluorine ion. Fluorine ion really wants to hang out with this hydrogen, and so it will accept that in solution. A monoprotic acid, again, hopefully we understand this terminology. Monoprotic acid means it only donates one proton per molecule, and there are some that we call polyprotic acids that can donate more than one. Diprotic, for instance, would be two protons, H2SO4. Primarily, it only liberates that first hydrogen, and then the HSO4 minus becomes a relatively strong base. It wants to stick that hydrogen back in there, but we'll talk about that. HSO4 2 minus is basically, or HSO4 minus is a weak acid. It doesn't tend to lose that second hydrogen. Same with the triprotic here. A phosphoric acid tends to just lose that first initial hydrogen, but we define it as a triprotic acid. Lewis acid. Here's where we need to talk about Lewis dot structures. To identify a Lewis acid, you have to see if it has the ability to accept a lone pair. These are usually going to be positively charged ions, or things that have room around that central atom for another bond to exist. And so Lewis acids would be what we call, like I said, an electron pair acceptor. A Lewis base is an electron pair donor. My favorite example is ammonia, NH3, and so we'll look at that. It's got that 2 lone pair up the top. It can donate that lone pair, and so hopefully we can kind of see how that rolls out. Definitely we'll have some homework in there. We do need to remember how to do Lewis dot structures for this, so if you don't remember how to do Lewis dot structures, go back in your notes, take a quick gander, and then if you still are unsure, definitely get a hold of me today before you start looking at these two forms here at the end. Okay, practice your Lewis dots. They become super important. Hopefully I understand it was quick. We will be meeting today, so don't panic. Compare and contrast different models of acids. We have hydrogen ion donors and hydroxide donors, which is Arrhenius. We have Bronsted-Lowry, where we have a proton donor and a proton acceptor, so acid base. And then we have our final form, our Lewis, where we have a electron acceptor, electron pair acceptor, which would be your acid, and an electron pair donator, which would be your base. Hopefully that helps a little bit. Again, be ready for section 3 tomorrow, a little bit more mathy. We have 1 through 3 on page 464. Again, you can find this on over on Google Classroom if you're part of my class, or yeah, that's the spiel. You can get this to me, you can get me a picture of it again, or it's much easier just to get it filled out on that Google Classroom. Just remember, it's short answer, so I will go back and regrade your work after I see your responses. You guys all have a marvelous day. I am going to get to work making a couple more of these. So have a great day. Bye.